Good day, everyone. So let's see the topic informed search strategies. We are going to learn about A-star search, and we already know that what is f of n. Okay, how to generate this f of n through g of n and h of n. It's going to have some cost values on h of n. We are going to add up those values with the cheapest cost that is going to be attained by the edges, and adding both, how we are attaining the f of n. So this is how we are going to see in A star. So in greedy searches, which you have already seen before, minimize the heuristic h of n, which is an estimated cost from a node n to a goal state. So from that h of n, we know that in greedy search we take heuristic h of n value, and from there we estimate the cost to attain the goal state, right? So although the greedy search can considerably cut the search time, which is efficient, but the solution which is being produced by it is not going to be optimal. Okay, and the same way in ununiform search, we are going to only take g of n, the cost between the edges, which also will not give us a complete or an efficient solution. The solution in greedy search is efficient, but it's not optimal or complete. Okay, here we can attain, in uniform search we can attain optimal and complete, but we cannot attain a efficient value. So we are in search of a new strategy which is called as the A star, right? Fine. So the A star, how it's already we have seen the g of n and h of n. So adding these values, we are going to attain the f of n. So g of n is nothing but the cost to reach a node from the initial and cost to far up to the node n, and h of n from n to the goal, how much it's going to take. That also we are going to conclude. So let us take an example. This is the h of n values which is being given, heuristic values, and these are the g of n values. So this is a map from A to I is my goal, and this is my initial state. And having these cost values and having the heuristic cost values, I'm going to calculate f of n. Okay, I'm going to start from the node A, which is going to be the initial node. From there, where all my map is going to go, the graph is going to go to C, E, and B. So how I'm going to calculate h of n plus g of n, right? So this is going to be my g of n, and this is going to be my h of n. Okay, so using h of n and g of n, I'm going to calculate, right? So the path g of n values are being given over here, and the h of n values are given over here, right? From A to C, it's going to be 4, 4, 7. How this value has been got? So I'm going to take 118 is nothing but the node values, that is g of n, plus h of n is nothing but, what is the value of C here? It is 329. So 399 plus 118 gives you 447. So same way to E, attain E, how much is going to be my g of n? 140. And how much is going to be my D destination to the destination D? This is going to be it's going to be 253. So 253 plus 140 is going to give you 393. So this is how B is also calculated. From here, which is going to be my least value? 393. From there, I'm going to extend the values. And again, what I'm going to do, I'm going to add the values. So when it's going to be g of n, I'm going to take 140 plus 180. So it's going to be 140 plus 80 plus what is the g value here? 193. So altogether you get 413. Can you understand how do you get this value? Right? Same way f is being calculated. From here to here it's 140 plus 99, which is g of n value, and f is going to be 178 plus 178 h of n. So which gives you the total of 114. So which is the cheapest? G is the cheapest. So from here it's going to extend. So this is how the next value h is being calculated. From there the goal is being calculated. From G to h only one path is there. So from there we reach the goal. So how much it's being estimated? 418. So this is going to be the final attainment. So through F I am reaching I, which is another goal state, but which is efficient? 418 is efficient. So this is how A star works. So the memory that depends on the heuristics. If g of n is constant, you can save some memory. If h of n is a perfect estimator, A star goes straight to the goal. Okay. If the initial state itself we are finding out if it is the goal, so those will give you more effective or efficient values. The quality of solution depends on h of n. It can be improved that h of n is optimistic, never overestimates the distance to the goal. Then A star finds to be the best solution and the shortest path to the goal. So this is all about A star, which is very important in your subject and a repeated question in university. Thank you all.